Hello, we are going to begin part 2 of our analog input program, or Theramin, part 2. We're going to print some program data to the serial window in this version, so this would be a good time to listen to my lecture number 5 on serial I/O, or printing, if you haven't listened to that yet, because we will be using those commands. Okay, in the Theramin 1 sketch, we converted light intensity to digital data using the built-in Arduino A to D and converted that, in turn, to a frequency, which is proportional to that data. But what were those frequencies? What if we wanted different frequencies? And how do we quiet the noisy thing when we're not using it? First, let's look at the digital data being produced by the photoresistor. This is going directly into our tone command's frequency input, and it is whatever it is. We have no control over that. To do this, I am going to add the command serial begin 9600 to setup. This tells both the Arduino and the laptop they will be sending data back and forth at 9600 bauds. A baud is a data symbol. For historical reasons, there are usually 10 bits of binary data being sent for every byte, 8 bits of data. So you divide bauds by 10 to get an approximate number of bytes per second for your data rate, or 9600 bytes per second. For this, or for text, this is about 9600 characters per second as well, or a couple of typed pages. This is not a graphics-capable data rate. Okay, so over here on the right, we have our Theramin 1 program. I am going to go over to, I'm going to click on it to activate it. This is the one that we wrote before. I'm going to do a file and a save as, and I'm going to call this one Theramin 2, Arduino directory. Theramin, Theramin-2, Arduino, save. Okay, up here at the top, I didn't put version 1 for version 1, but I'm going to put version 1, very basic. And then I'm going to version, it should have been V 1.0. And then I'm going to steal that line, command, or just mouse down, scroll across, then command C to copy. And the end of the line, new line, command V to print, just like any other Mac, version 1.1. And I'm going to say add map command. We'll get there in a few minutes. Okay, pins are still the same. This is the very same setup. The Thera pin is analog 0. The speaker pin is digital 12. Setup has the pin mode of the speaker pin as output. Loop down below is creating a data variable integer from the analog read command attached to the Theramin pin, which is of course taking the analog data from our light, from our photoresistor. And we have the tone command outputting through the speaker pin the data that was just received, and then waiting for 20 milliseconds so the tone command has long enough time to actually produce some sound, not real fast. Okay, first thing to do, back up here in setup. At the end of pin mode, I'm going to say capital SERIAL dot begin. That's called a method inside serial. And we're going to tell it 9600. That's what the dot does. Baud, semicolon. I can just put 9600 baud, except anyone who does this already knows that. Doesn't matter what order these commands come in. Serial mode and pin mode and serial begin have no interaction on each other, so they're fine. Okay, to print one number per line, we're going to want to add something after we have created and filled our data command. So I'm going down here to loop, going down to the end of data, and I'm going to hit return. And this gives me a new properly indented line of data. And I'm going to say, I want to look at it. So serial dot println, we are down on item number 4 on the script, if you're following that. And serial print line, I call it print line because it prints one item per line. Open parentheses data. It's going to print out that numeric value. Okay, if we print it out, even though I called 9600 baud kind of slow, it's still really fast for human reading. So I'm going to put an additional delay into this line, D-E-L-A-Y, about 200 milliseconds, anywhere from 100 to 200 milliseconds, depending upon how fast a reader you are. And this is just a deliberate slowdown so that we can see the numbers nicely. You can put C on 2 lines, delay down here. That was not meant to be that. That was meant to be a return. Or you can put it all on 1 line. This is really bad C programming practice, but in this case, I'm going to remove this whole line later when I'm done with it, and 1 comment in front of it will knock the whole thing out. Okay, I think we're ready to go. So I don't have my speaker connected right now, but I do have, because it's annoying, but I do have the Arduino attached. So let's upload it, compiling the sketch, uploading. Okay, we're down at item number 5. We're going to scroll over to the right here, move my little cursor up and down. See that thing that looks like a little magnifying glass icon, says serial monitor? Click on that dude. And the serial window will open in the middle of your sketch. And it is right now printing out the data that is coming in from my photoresistor with a desk lamp about 2 feet above it. And it was 100 watts or not. It's a compact fluorescent. And I'm getting something close to 947, 948, 949. Bounces around a little bit. That's one of the problems with analog data. That's one of the reasons why you go to digital. All right, so let's put my hand over it. And immediately it drops. If I raise my hand up a bit, kind of let the light shine on it. If I bring my hand down, you can see the number goes down. And depending upon how low I want to get my hand, I'm just about touching it at this point, I could probably hit about 650, yeah. But if I keep my hand at a comfortable distance, that's pretty comfortable. 730-ish, 730-ish. Okay, that was what I wanted you to know. 950 to somewhere around 730, depending upon how I hold my hand. All right, we'll close the serial window now, little red dot on it, and we're going to put a note in here. Read the photoresistor, and I'm going to say that the data range is 730 to 950, because we're going to want that. All right, I just put that right above data. You can put that comment anywhere you want. You just want to remember those 2 numbers. Okay, let me scroll up the script window over on the left here. All right, going back to loop. First thing I'm going to do is comment out serial data. I don't want it slowing down my Theramin program. Next thing I'm going to do is go over to this tone command where it says output data as a tone or frequency. Well, right now it's just data, and it happens to be 730 hertz to 950 hertz, and that's just the luck of the draw of my light, my photoresistor, and my regular little resistor in series. Okay, we are going to use something called the map command to convert this input range of 730, 950, arbitrary, to a designated output range, which is going to be frequency. It can be anything I want. I'm going to create a new variable, FREQ. We're on item number 9 over on the left. And I have 750 typed in there. Depends upon where I hold my hand. I'm holding it a little bit differently now, and I've gotten 730. Doesn't matter really. int, create a new variable, create them and use them. FREQ equals map. Map does kind of what you might imagine map does. It takes data as its input value. It says that data has a range that goes from a low of 730 or 750 as I got earlier, up to about 950, comma. These are all parameters. Everyone is separated by commas. Okay, so 730 to 950 is the input. Then I can designate anything I want as an output. So I'm going to say I would like it to go from 500 to 1,000. One more zero, semicolon. Okay, I have now converted 730 to 950 to 500 to 1,000. That's kind of similar, you know? I'm going to change that from, say, 1,000. This is going to be really squeaky, to 2,000. So we're going to 2,500. We're going to jump up here a bit in frequency from our input data just to show we can do it. Okay, tone, speaker pin. It's sending the raw data still. So what we want to do is go up here, double click on frequency so I don't have to type it. Double click on data, do a Command V to paste. And now frequency is the output of the mapping command producing 1,000 to 2,500 hertz. And that's now the input to our tone command. We still delay for 20 milliseconds. We check that serial print line is commented out, and I'm going to go up to the top and upload it. In the meanwhile, I'm going to go reconnect my speaker, which was annoying me, and see if we can turn it on. There we go. All right, so that's the bright light. That's 730, no. Yeah, that's 950 being converted to high end of the input range to the high end of the output range. Full light, 950, 2,500 hertz. Kind of an annoying squeal. Ah, that's better. As I lower my hand towards 730 data, I'm getting down to about 1,000 in my frequency, I imagine. I don't have a frequency meter here. And I get a little bit lower if I work at it, and I can certainly go back up to a high again. All right? Now, we could try experimenting a little bit. The script ends here where it says, give it a try. I'm going to unplug this for a minute. Down there, item 10, it says try this on several frequency ranges, such as 1,000 to 2,000 and so on. Comment out the data print line. We did that. Note piezo speakers are not great low frequency performers, and they usually cut off between 250 and 500 hertz, usually closer to 500. But they'll go way up, often beyond 10 kilohertz, which is a real squeal. And in fact, it's almost too high for me to hear. So before I turn it back on again, although I've told you to stop and I'll wait for you, I'm going to play around a little bit. I'm going to go change 1,000 to 250. And I'm going to change 2,500 to 500, and we'll test the low frequency response of our Theramin. So I'm going to upload it again. I will reconnect my speaker wire, which is my on-off switch at the moment. Okay, so that is now 950 is the high frequency, and I'm outputting 500 hertz. And that's what it sounds like coming out of a crummy little digital piezo speaker. Headed down towards 250. Yeah, it's sort of doing it. Okay, it's not too bad, but it's not great. I think it sounds a little happier as it gets towards 500. All right, and we'll try one more here. I'll go from 2,500, I'll just add a zero, up to 15,000. Okay, we'll push the upper limits too, 15000. And so I will upload the program. It stops for a moment while the old program is erased. The new one is, ooh, listen to that. It's graveling. I don't know if you can hear it. Okay, So if I cover it up a bit and I get away from 15,000, which it evidently can't do, I get a really high-pitched whistle. I don't know if the computer's recording that. And as I come down towards 2,500, it's still a pretty high tweet, but that's probably 2,500, and I don't know if that's 10,000, but it's not getting up to 15,000. Full light is just sort of gravelly sound. Now, interesting, if I go down probably below 730, you notice I'm beginning to get weird stuff as I cover up my photoresistor very thoroughly, and I'm probably below 730 with my data. And it goes from being probably 2,500 to sort of possibly interesting, sort of twittery stuff, although that's certainly not what you want if you're creating music, to a thorough cover-up, and it stops. I get a little bit of fuzzy stuff and then nothing. This is bad data. Okay, it's bad data when it gets to be too low, probably below 730, and it's obviously bad data when it gets up above 15,000 because I can't hear anything. So our next program, Theramin 3, will be how to deal with bad data. Thank you.